Also, precipitation amounts increased, especially in the Galapagos Islands on the coast and in the highland. Only the Amazon basin shows a little bit of precipitation decrease. Also, maximum temperatures and minimum temperatures increased in all regions. However, this study was based on this station network because it was an analysis of 50 years. 1960 to 2010 was the data series, and this was the station. As we see, for Galapagos Islands, it's only one station. And for the Amazon basin, it's only 3 stations. In the north of the coast, there is no station 2, which they can use for this analysis. These are average values for the whole region that I showed you before. These are average values for the whole region. It's not at every point the same. Yeah. For this, the maps resulted in this resolution. Sorry for the image quality. It's the same quality in the report, so I couldn't make it better. The same quality, but there you can see interpolating this poor station data. You get a precipitation result of this. We see the northern of the Amazon basin normally has a surplus of precipitation. Only the southern has a deficit. But in mean value, it's a reduction of 1%, more or less. Here, the same for the mean temperature, the same resolution. We are doing here ecological studies or ecosystem studies at local or regional scale. So this map resolution is not really helpful for our investigations. So we tried to analyze the climate change in the protection forest Corazón de Oro, Bosque Protector Corazón de Oro. This is the letters in Spanish. Yeah, in Southern Ecuador. For this, we evaluate first the available station data in the zone. Then we characterized the actual climate in the zone. And finally, we calculated some trends or climate indexes respective to temperature and precipitation using Excel and the software Climatex 1.0, which permits the calculation of different climate indexes. Okay, the study area, we're in South Ecuador, between the provinces Loja and Zamora. The protection forest on Corazón de Oro and provide important ecosystem services for the regional and local population, especially the water supply and also water for the hydrologic power plant that you can see when you're going to Zamora. On the left side, they constructed a new hydroelectric power plant. This is Del Santinasiagua con 118 megawatts the potential. The elevation in the study area is more or less from 1,400 meters above sea level to 3,400 meters above sea level. Here we can see the limits between the province of Loja and Zamora's Chinchipe. This is a mountain chain which divides the Amazon basin from the highlands of Ecuador. And the 4 meteorological stations we used for the analysis, this is San Lucas, La Argelia, El Tiro, which is the station in the transition zone between Amazon basin and the highlands, and the ECSF, the meteorological station in the San Francisco Valley. Yeah. Vegetation in the study area, it's called protection forest, but as you see, forest is the green one, or the green color. Paramo is the orange color, but all the white or yellow color are pasture. So it's intervented by human activities too. It's called protection forest, but you see big parts are intervented. This is a map from 2018 from GIZ, yeah. But it's intervented up to the Paramo. We can see pastures here, yeah. But this is only side. If you want to ask me why there's a hole in the middle, I don't know it. So they only make the protection forest like this. There is a hole in the middle, but it's not protected, the center of the area. Okay, meteorological station data available from Argelia and St. Lucas. We have dates from 1964 to 2015. I have to say, normally we have big gaps till the 80s in this station. These are stations from INAMI, and we took 2 stations from the German investigations groups. This is ECSF and El Tiro. But there we only have date from 1998, when the project started here, to 2015. So for the study, we take this time period, 1998 to 2015, that we can compare the tendencies or the trends of all stations. Only station which has only precipitation data available is San Lucas. The other stations has also temperature data. Okay, the methods we applied for this study was first the quality control of the data. Normally, temperature shows a normal and distribution, as we can see here. So we applied to find a credible range of the temperature data. 3 standard derivations, more 1 degrees Celsius, to avoid that extreme values which can occur sometimes are not eliminated. So when we find the range or the credible refill, and then we checked the daily variation too, that the maximum temperature has to be higher than the minimum temperature in a specific day. Precipitation does not show normal distribution, so we eliminate only the negative values, which are sometimes in the data series of INAMI inside. There are negative precipitation values and values over 100 millimeters a day. This is a personal comment from INAMI. He said in the area of Loja, daily precipitations over 100 millimeters, it's not possible normally. Yeah, this was the quality check. Then we had our data series from 1998 to 2015 for each station. Then we want to characterize the climate in the study area. Therefore, we calculate the monthly values. If 80% of the temperature data is available for 1 month, for one specific month, these are 24 days, and precipitation 90% on 27 days a month. This is important because precipitation is more variable in time and space, so we put 90%. Then we calculated mean monthly values, all the period, all data from January were averaged to get the mean monthly values, and the mean monthly values then were used to calculate the mean annual values, averaging the temperature or summing up or adding up the precipitation. The result is this, is only in 2 stations. Argelia, it's the representative station for the Highlands, and ECSF for the Amazon basin. As we can see, we have different precipitation regimes. In the Highlands, the precipitation peak is in February, March, and in the Amazon basin in June. Yeah. Also, the driest months is September in the Highland and November in the Amazon basin. The mean temperature is more or less the same, around 15 degrees, because both stations have more or less the same altitude, above sea level. Annual precipitation, perhaps Argelia more or less 1,000 millimeters a year, and in the ECSF we have 1,800 or 1,900 millimeters a year precipitation, in average for this time period. Okay, then we calculated the basic climate indexes, first in Excel that we validated with the software area climate index because it's calculating the same values, and we calculated some additional values to understand why we have these changes. There are some indexes for precipitation. Area 10, for example, is precipitations in 1 day over 10 millimeters. Area 20, over 20 millimeters a day. Percentile over 95, it's heavy rainfall, or extreme rainfall, the percentile 99. And then some additional temperature indexes with cold nights, warm nights, cold days, hot days, and minimum temperatures. Okay, as a result, these are the maps interpolated. These are the annual maps for our time period from 98 to 2015. Minimum temperature, mean temperature, maximum temperature, and precipitation. Minimum temperature in the night, more or less between 5 degrees in the Paramore area and around 10 or 12 degrees on the valley bottom. Mean temperature a little bit higher, 7.5 in the Paramore, and more or less, 15, 20 degrees on the valley bottom, and the maximum temperatures in the valley bottom go up to 25 degrees in the afternoon. Precipitation, there is clearly visible the climate or weather divide of the mountain chain here. The Amazon basin is wetter, around 2,000 millimeters or higher, and in the highland we have precipitations between 1,000 millimeters and 1,400 millimeters. But it's clearly visible, the divide of the mountain chain between Amazon basin and highlands. So we calculated first the basic indexes. I don't have so much time, so only minimum temperature, mean and maximum temperature. Really interesting, mean and minimum temperature are reduced in the Amazon basin. The first two stations are from the Amazon basin. Okay, Tiro is the transition to the highland, and the other two stations are the highlands. So minimum and mean temperature decreased in the Amazon basin, and contrary in the highlands increased. Maximum temperature on the other side increased in the Amazon basin, but decreased in the highlands. Yeah, these were our results calculating the tendencies or trends with Excel. The same with the precipitation on the other side. Precipitation is reduced in the Amazon basin and increased in the South Ecuadorian highlands, was the result. So we compared it to the software area Climadex, our values, and as we can see, temperature, minimum and maximum temperature is more or less the same gradients. I have to say the software is more strict than we. The software only takes into account months with maximum 3 days gaps inside. Yeah, we used 80% of the data. 80% of the data of the months is present. We calculated the monthly values, but the software is stricter. Annual values only is calculating when only maximum 15 days a year are losing there. But we see our gradients or our trends are more or less equal to the to the trends calculated with the software. The same is valid for the precipitation. This is our Excel calculation, and this is the calculation with the software. Again, the precipitation is reduced in the Amazon basin and increased in the highlands. As I said before, El Tiro is directly in the transition or on the mountain chain between the Amazon basin and the highlands. There we can see how the trends reduced to the other side of the mountain chain. The trends are stronger in the HCSF. When we are going to the highland, these trends are reducing, yeah, into the highland. So the question is why? What happened with the precipitation and the temperature? Why we have this distribution of these trends, or found these trends for the Amazon basin and the highlands? When I show you the maps of the basic indexes. Minimum temperature, yellow is reducing, and red color is increasing minimum temperature. Here we see a green line. This is again the limit or the mountain chain between Amazon basin and highlands, and it's clearly visible. Minimum temperature increased in the highlands, decreased in the Amazon basin. The same for the mean temperature, increases in the highlands and decreases in the Amazon basin. Maximum temperature is different, the opposite. It increased in the Amazon basin and decreased in the highlands. Precipitation map, or the trends for the precipitation, reducing in the Amazon basin and the highlands, an increase in precipitation. So we calculated the other indexes to find out on what happened. As we can see, extreme events, or in the Amazon basin, all types of precipitation are reduced. Extreme rainfall, heavy rainfall, days with precipitation over 20 millimeters and 10 millimeters. The same for El Tiro, but with reduced trends. Only heavy rainfall is a little bit increasing there, but this may be the influence from the highlands, because it's really on the mountain chain situated in the station. And in the highlands, we can see that generally all types of precipitation increased, especially the heavy rainfall, and for San Lucas, the extreme rainfalls. Yeah? The additional temperature indexes. There we have TN10 as the cold nights, warm nights, cold days, and warm days here. So we can see, again, the contrast between Amazon Basin and the highlands. The cold nights are getting more frequent in the Amazon Basin, but hot nights or warm nights are reducing. In the highland is different. The cold nights are reducing and the warm nights are increasing. In the afternoon or during the day, we have the same situation. Cold days are reducing in the Amazon Basin. Warm days are increasing. In the highland, we have the opposite. Cold days are increasing, and hot afternoons or hot days are decreasing. This may be due to the cloud cover, because as you know, if you have cloud cover in the night, outgoing radiation cannot pass in the space. So generally, we have warmer nights. Yeah. And in contrast, in the afternoon, it's the same. If I have a cloud cover, temperatures are not getting so high in the afternoon because the clouds are reflecting. So we can say, or perhaps conclude, that we have an higher cloud cover now over the highlands and less cloud cover over the Amazon Basin, because cold nights are increasing. So I don't have a cloud cover, all the energy is going out to space. In the afternoon, I don't have a cloud cover, so the afternoons are becoming hotter. Yeah, maybe a reason for this, but I don't have so much time to explain it, so only the conclusions. I know normally for climate analysis you need 30 years of data. Generally, or many countries do not count with this information, and the meteorological station network often is really spare. So as the Climatex software also said, you need minimum or at least 50 years of data that you can calculate tendencies. This data series now we have and for the station, because the project started in 98, so we have the time series and can calculate the trends. If I want to have, for my ecological or ecosystem studies, I need a resolution at local scale, and therefore I need at least 3 meteorological stations to interpolate or extrapolate the data. For the results, we have seen that we have different climates in the Amazon Basin and in the highlands. This is caused by the eastern escarpment of the Andes, which are a climate device or weather device. This is a barrier effect, so we have different precipitation regimes. Precipitation amounts increased in the Ecuadorian highland by larger and more extreme rainfall events, as we have seen in the indexes, which may be due to the higher evaporation because mean temperature increased and a higher cloud cover. Yeah? Therefore, for the higher cloud cover, our argument is the minimum temperature increased, but the maximum temperature decreased in the highland. On the other side, Amazon Basin showed the opposite. Precipitation decreased because we have lower minimum temperature, higher maximum temperatures, which means that we have less cloud cover, which affects the daily radiation cycle and the temperature. But also the less cloud cover may be due to the deforestation in the Amazon Basin. Pontes et al. This year has published research about protected areas in the Amazon Basin. They're getting less water input, and he concluded that it is the deforestation. There I show you a map of the core areas or the core forest areas of the Amazon Basin from 1915 to 2020, that you can see it can be possible because the vegetation is recycling the water, evaporation, precipitation, runoff, and brings or dries the humidity to the Andes. But I don't have the forest there. There's no recycling. The water goes back to the Atlantic Ocean. Only to think about that this can be true. For this, we have less cloud cover in the Amazon Basin. I only have to say thank you. Have a nice day. If you want to see the literature used here on this page. Thank you. Questions? it's very local. It's only this part I said from Saraguru to the city of Loja, more or less, because from the south we don't have station information, as you saw in the map of the station network from Inami. In Zamora we don't have a station. This is really pointly, I said, from Saraguru more or less to Malacatos or Vilcabamba. This is more or less the region between Amazon Basin and Highland where we have this tendency for this part of southern Ecuador.
Would you like the trend of less precipitation in the Amazon and more precipitation in the Andes? You just can't say.
No, it was found. For this I put this other publication too. They found it too, but not only near the Andes, also in the Amazon Basin. This was a study from the eastern Amazon Basin, from Pontes et al. And he found the same, that precipitation is reducing over the Amazon Basin, not only near the Andes, so only on the eastern part.
Okay, thank you. Thank you for your presentation. And the next speaker is Mr. Boger, and the title is Environmental Literacy of Latin American Adolescents, an Example of Cuba.
So welcome to the second session, and it's a trip to quite another continent. It's a trip to psychology, and I would like to show you first results about the environmental literacy. Unfortunately not from Ecuador yet. We did the data, we collected the data from Cuba. So normally you start with a very easy slide, and then you make it even more complex until you finalize your talk. I would like to do it the other way around. It means I start with a model. The model how to measure environmental literacy. This was the result of about 20 years of research, and of course I help you to make it understandable. You easily see that we have three, let's say, columns. That means literacy has something to do with knowledge, has something to do with attitudes, and has something to do with behavior. All three columns are difficult to measure. Even knowledge is very difficult to measure. But this more or less puts together the model and how the three columns interact with each other. It means knowledge interacts with attitudes, interacts with behavior, behavior interacts with attitudes, and so on. This is more or less the model, and I try to explain you some pieces of the model before I really jump to the data of the Cuban secondary school students. The good thing is that we really have 20 years of experience to measure attitudes and behavior. And I would like to start with attitudes because this was our main research the last 20 years. And to show you the model which was published 20 years ago, 1999, you see that we have more or less just two umbrellas. One umbrella is the preservation, that means the preference is to preserve nature, to protect nature, and the other umbrella is the preference to use nature, even to exploit nature. And the model is a hierarchical model. That means we have some items. The items group together to some attitudes, and the attitudes group together to some values. That means here we have, this was the model where we had about 20 items. In the meantime, we are able to do it much less, because when you measure attitudes, and you come to pupils and say, okay, by the way, respond to my questionnaire with 200 items, the students stop doing this. It means you need as less items as possible. And here you immediately see we have an hierarchical model, and for the statistics freaks in the audience, this model was really the first shot to show it might work. And just to show you some example, very often you find a gender difference. That means girls are normally more in favor of preserve nature, boys are more in favor of utilizing nature, but this is not always the case. I just have to warn you. It depends. So, then something revolutionary happened, because in my field, every researcher is ignoring the researchers are ignoring each other. Nobody is having a look what the others are doing. It means there was a group 5 years after our first publication in New Zealand. They said, no, we don't believe it. And they repeated it and made it even more complex. This was a psychometric group. And I don't go into the detail, but you immediately see, wow, there's the first time that an independent confirmation of the model was done in the field of, in our field of education. And the story went on 5 years later or 7 years later. American group used it. By the way, the 2 MEV means 2 major environmental values. It means what I told you in the beginning, this high hierarchical model. They used another kind of statistic, but you immediately see, well, again, you have 2 main umbrellas, and with the 2 main umbrellas, you can really easily measure the attitudes of young kids. Finally, this was an African group, 2013, I think. They confirmed it the same way. Just to summarize to you, I think this picture is the best way to summarize it. Here we have the 2 values, preservation, utilization. Then we have several umbrellas under that. Remember the Australian, the New Zealand guys, they took 12 umbrellas. Our first publication, 1989, came out with 5 umbrellas. That means these are primary factors, and under the primary factors, the human beings, they are the items. And then, of course, under preservation, you could have several attitudes, you know, ecocentrism, stewardship, balance of nature, enjoyment of nature, whatever, you know. There's everything possible. And utilization is the anthropocentrism, the exploitation, to see that there's a human dominance, or even to see which kind of nature is altered and which kind of nature is the original one. So, let me summarize. That means we have a model which is unique, because it is 5 times independently confirmed. Just last year was a study in Malaysia. That means South Asia. Nowadays we know about 33 languages. Maybe there are more, because we just know about these languages which did publications. By the way, I need confirmation for this. Somebody sent it to me, and I still don't know whether it's fake or not. So right now the situation is this way, and here you see why I give this talk about in Ecuador. All over the world we have publications, some were from us, some are from others, but here you see there's some white continent. Cuba, okay. We had some 2 studies in northern Mexico, but that's it. We really have to expand our model to South America too. Just to give you 2 slides, what could be done with it. For example, this is a study which we did last year with some French colleagues, where we say, okay, we have our attitude model, our value model. How does it fit to GMOs? How people think about GMOs? And you immediately see the people or the pupils who prefer using nature, you see relationships to GMO items, but not the subjects who are in favor of preserving nature. This is the good advantage of this model. Or another one, which of course is our core business. Here you see each dot is a pupil. And you see a sublample, pupils with low values in preservation and high values in utilization. And these pupils are spending 1 week in a national park in the middle of nowhere. No mobile, no pub, nothing, just in the middle of nowhere. What happened with these kids? And luckily we found this result. That means these kids were much more aware after the 1 week intervention about preservation, and they were more critical about utilization. But I have to warn you, we did about 30 PhD works. This was the extreme. Normally you don't have such a wonderful picture. So, we applied this questionnaire to secondary school students in Cuba, age about 14 years, gender balance more or less okay, but a little bit more girls. Of course, when you do a questionnaire in another country, you have a problem of culture, a problem of language, but this is the usual way. Somebody is translating it, another one is translating it back, and if you have differences, you need discussion. That means this is a very established way. So, you see the results, very clear. This is the factor analysis. You see very clear factor structure, no cross-loading above 0.3. That means the questionnaire is wonderful working. To be honest, we lost some items because you immediately see these are not, normally these are 14 items. Here we cut it to 10, 11 items because with the cultural context, some items make no sense. And therefore we normally drop it. But it's stable enough. Here is for the not Spanish speaking, the English version of the questionnaire. And yeah, I don't go into the detail because I don't have time for this. This is another way to show the two independent factors. So, now I showed you a little bit the background of attitudes. Let's jump to the behavior, which is more complicated, but luckily there is also a scale developed by some Swiss teams, 1998, and this scale was developed for adults, actually for union members, and we used the decade after to adjust this to young kids, to secondary school kids, to really make sure that the scale is also working for our age group. This is quite another analysis because the Swiss guys used rush analysis, and the philosophy behind this, when you ask about reported behavior, first of all, you have to make sure that people are not lying. And second, you have to make sure that there are behaviors of different difficulties. Because some behaviors are very easy and some are very difficult. A difficult item would be, I never use a car for moving around. You know? It's very difficult. Or others are much easier. And here you see the difficulty. You immediately see, okay, there's a good distribution of the items. These are the different items. Of course, I cannot go into the detail. The Swiss model really has the big advantage that you come out with a number. And you could use this number to have a look how the relation to other variables is. So, and this is the numbers. This is my main important picture right now. First, you see here the general ecological behavior, and here you see the preservation and utilization, the two attitudinal preferences. Of course, as more as you prefer the protection of nature, as less you prefer the utilization. That means there is a negative relationship. Sometimes it's very strong, sometimes it's not. It depends on the sample. But if you look to the behavior, you see people who have preferences to protect nature have a strong relationship to the general ecological behavior scale, a positive one, while the utilization has none. Of course, this could be discussed in more detail, but for the educational intervention, it means you should approach young kids not with a negative news, you know, climate change, blah, blah, blah. You have to come with positive messages to the kids, to really enjoy nature, to jump over to protect nature. This is the message for the education, which, of course, will be the next steps which we were doing. To sum up, we are sure that our scale is working very good in Cuba for these attitudes and for the behavior. Of course, this big backpack of knowledge is not even approached. This is more difficult. First of all, what is the knowledge which is important? Second, how could you put knowledge into, let us say, 30 items? This is the difficult thing. We started already doing this, we will use PISA items. PISA items means these were used all over the world, and they had already some standards in evaluation to measure this, and then hopefully in 1 year we will see how the model is working in Cuba. I expect some differences. This is the model from Germany. I expect really some differences. The one of you who have been in Cuba, they know Cuba is quite another continent than Europe. That means there should be some differences also in the studies. Thank you very much.
Thank you for this very interesting presentation. It's a topic, a complete different topic to the others, and I think it's a nice contribution to the symposium.
Yes, thank you, Franz, for this very interesting talk. So I have a question on one of your last remarks. You say you have to convince the pupils with positive news, but contradicts it not the movement of Fridays for Future, which are highly motivated by the negative messages from the scientists?
Yeah, I should not have said this because I had the data here. Now, with this model we did about, I would say, 25 interventions. And the first thing is interventions, you have to follow the syllabus, otherwise you are killed by the ministry. It means otherwise you cannot enter school. The second thing is, very often teachers come to the students and say, they climate change, blah, blah, blah. But the kids are not responsible for this. The grandfathers are responsible for this. That means you cannot blame the kids for doing this. And therefore, this kind of approach is useless. This is a general message, not supported by my data here, because I should have shown other data for this. But this is a message for all of you, because most of you, sooner or later, will end up in convincing young kids to be better citizens than we are or the grandparents are.
Franz, maybe I missed the point, but did you see a general difference between the behavior of the Cuban kids and the European kids?
Not yet, but this is the plan. Right now, yeah, the problem is if you are measuring some minerals or some plants or whatever, it's easy because you count them and you come to a number. And if we are measuring attitudes or even behavior, you should be sure that the number is a number. And therefore we did this study just to be sure that the number is a number. And then we go on, and I expect big differences because Cuba is really the most different country which I know from all over the world because of the different history. That was the
Thank you very much. I have just a question. I'm not sure if I missed this at the beginning. What was the age of the participants of your study? Because maybe this may have also an influence on experiences, on perceptions about issues like climate change or different issues.
I'm not sure whether I caught your language. You talked about age?
Yes, of
yeah, our
the
age
students.
group normally is secondary school, which means 11 or 10 to 18, which is a problem because if you would focus on primary school, it would be much easier to intervene. But if you have ever given a questionnaire to a 10-year-old or a 9-year-old, it normally ends up with a disaster.
Yes.
That means this is the problem. And therefore we focus on secondary school. In Germany, secondary school starts with 10, 11. All over the world, it normally starts with 12. But end of fourth graders normally can complete the questionnaire.
Yeah, thank you very much.
Okay, thank you. Thank you for your talk. And thank you. So I think the next is poster. Yes, poster session. Thank you.